On the night of December 28, 2024, humanity's gaze was once again drawn to the cosmic ocean that surrounds our tiny island of a world. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, flagged a faint, fast-moving object. At first it might have been dismissed as just another space rock, but as astronomers refined its trajectory, a startling truth emerged. This object, designated 3I/Atlas, was not one of ours. It was an interstellar visitor. The third such object ever detected. Its arrival sparked a firestorm of excitement and debate. Preliminary estimates suggested it was a behemoth, perhaps several kilometers in diameter. That made it significantly larger than its predecessors, Oumuamua, 2I/Borisov. It was also moving at a breathtaking speed, on a hyperbolic arc that would carry it back into interstellar space. What forces had ejected this colossal wanderer from its home system? This visitor arrived when our observational tools were more powerful than ever. James Webb Space Telescope, ground-based observatories across the globe. Humanity turned its most powerful eyes toward the enigma. The stage was set for a grand cosmic detective story. Understanding 3I/Atlas begins with understanding its path through space. Its trajectory is what definitively marks it as an interstellar object. Unlike planets, asteroids, comets which follow elliptical orbits around the Sun, 3I/Atlas is tracing a hyperbolic path. Think of it like a cosmic slingshot. It's moving so fast that the Sun's gravity can bend its path, but it can't capture it into a repeating orbit. This high velocity confirms it originated far beyond the gravitational influence of our star, having traveled for potentially millions of years through the cold, dark expanse between star systems. Its path is a one-way ticket through our neighborhood before it returns to the interstellar wilderness. The discovery by the Atlas survey in late 2024 was just the first step. Astronomers around the world quickly began tracking the object, using its position against the backdrop of distant stars to calculate its orbit with increasing precision. By tracing its path backward in time, they could estimate its trajectory before it entered our solar system. These calculations suggested an origin point somewhere in the direction of the constellation Cygnus, the Swan. However, pinpointing its exact home star is nearly impossible. Over the immense timescales of its journey, the stars themselves have moved, turning the search for its birthplace into a cosmic cold case of epic proportions. The object's estimated age as a wanderer is staggering, a silent testament to the vastness of galactic time. As 3I/Atlas drew closer to the Sun, our observations intensified. Telescopes, both on the ground and in space, were trained on this fleeting visitor. Early on, observers noted that the object appeared slightly fuzzy, not a sharp point of light like a distant asteroid. This fuzziness, known as a coma, is a classic hallmark of a comet. With the world's astronomical community focused on 3I/Atlas, a flood of data began to paint a more detailed, albeit still perplexing picture. The James Webb Space Telescope, with its unparalleled sensitivity to infrared light, was a key player. JWS performed spectroscopic analysis, breaking down the light from the object's coma into its wavelengths. This is like a cosmic fingerprint. It lets scientists identify chemical elements and the molecules present. The James Webb's initial findings were significant. It detected the unmistakable signature of water vapor. Water ice is the primary component of most comets we know. Its presence strongly supported the idea we were looking at a natural object. Further observations added new wrinkles. Spectra showed significant amounts of carbon monoxide, and carbon dioxide gas sublimating from the surface. These gases are more volatile than water ice. They turn to gas at much colder temperatures, far out in the solar system. The high proportion of volatiles suggested 3I/Atlas was relatively pristine. Likely it spent most of its existence in the deep freeze of interstellar space. Its composition was similar to 2I/Borisov, yet the sheer size of 3I/Atlas made the outgassing unprecedented. Was this a comet, a rogue planetoid, or something else entirely? Every scrap of data and photon of light was scrutinized. The mystery wasn't just about one object, it was about our place in a possibly interconnected galaxy. The stage was set for a grand cosmic detective story. On one side, established astrophysics, on the other, the tantalizing possibility we are not alone. The arrival of 3I/Atlas forced a confrontation of these views. As of September 2, 2025, the data continues to pour in. This essay will explore evidence for 3I/Atlas as a natural comet and the intriguing, controversial arguments for something far more extraordinary. Begins with understanding its path through space. Its trajectory is what definitively marks it as an interstellar object. Unlike planets, asteroids, comets which follow elliptical orbits around the Sun, 3I/Atlas is tracing a hyperbolic path. Think of it like a cosmic slingshot. It's moving so fast that the Sun's gravity can bend its path, but it can't capture it into a repeating orbit. This high velocity confirms it originated far beyond the gravitational influence of our star, having traveled for potentially millions of years through the cold, dark expanse between star systems. Its path is a one-way ticket through our neighborhood before it returns to the interstellar wilderness. For the vast majority of astronomers, the simplest and most elegant explanation for 3I/Atlas is that it is a comet. This conclusion is rooted in the principle of Occam's razor, the idea that the simplest explanation is usually the correct one. We know that comets exist. We know they are composed of ice, rock, and dust. We have observed thousands of them within our own solar system. Therefore, when an object comes from interstellar space, exhibiting the key characteristics of a comet, namely, a coma of gas and dust formed by solar heating, the most logical starting point is to assume it is, in fact, an interstellar comet. This explanation doesn't require us to invent new physics or invoke extraordinary phenomena. The evidence gathered by telescopes like the James Webb Space Telescope provides strong support for this hypothesis. The detection of water ice, carbon monoxide, and carbon dioxide is the smoking gun. These are precisely the materials we expect to find in a cometary nucleus. The process is well understood. As the kilometer-scale dirty snowball approaches the Sun, its surface warms, and these frozen gases sublimate, creating the fuzzy cloud we observe as the coma. The chemical makeup of this gas, while slightly different in its ratios from typical solar system comets, falls well within the expected variations for an object formed in a different planetary system under different conditions. It's an exotic cousin but still recognizably part of the same family. Furthermore, we have a direct precedent for an interstellar comet. In 2019, 2I/Borisov passed through our solar system and it behaved exactly as a comet should. It developed a coma and a tail, and its composition was found to be broadly similar to the comets originating from our own Oort cloud. Side-by-side comparison 2I/Borisov with its visible tail and 3I/Atlas with its large but less active coma. 3I/Atlas, while much larger and a bit less active for its size, appears to be following the same playbook. The differences in activity level can be explained by a number of natural factors. For instance, it might have a thick crust of non-volatile dust that insulates the ices below, or its surface might be structured in a way that limits the area exposed to direct sunlight, thus throttling the amount of outgassing. The scientific consensus, therefore, has solidified around the comet explanation. The object's behavior aligns with known astrophysical processes. Planetary systems are messy places during their formation, and it's widely believed that gravitational interactions eject countless icy bodies like 3I/Atlas into interstellar space. Our galaxy is likely teeming with these wandering comets, and we are only now developing the technology to spot them as they pass through our cosmic backyard. For most scientists, the arrival of 3I/Atlas is not a sign of alien intelligence but a thrilling confirmation of theories about planet formation and the dynamic nature of our galaxy. It's a natural wonder, not an artificial one. The case for 3I/Atlas being a comet is built upon a foundation of cumulative evidence, each piece kind of reinforcing the other. The primary argument, as we've seen, is its composition. The spectroscopic detection of H2O CO2 is a textbook signature of cometary activity. These are the building blocks of comets throughout our own solar system. While the exact ratios might differ, their mere presence is really powerful evidence. It suggests that the fundamental chemistry of planetary system formation is similar across different parts of the galaxy. While the comet explanation is the scientific frontrunner, a more provocative and tantalizing theory has been advanced by a minority of thinkers, most notably Harvard astronomer Avi Loeb. This alternative hypothesis suggests that 3I/Atlas might not be a natural object at all, an alien probe, a derelict craft, a solar sail. This line of reasoning stems from treating the object's unusual characteristics not as natural variations, but as potential anomalies that point toward an artificial origin. The argument begins with the object's immense size combined with its somewhat lackluster cometary activity. If it's a comet, why isn't it putting on a more spectacular show? Professor Loeb and others suggest the faint coma might not be from sublimating ice at all. They propose we could be observing something else. a cloud of dust kicked up by micrometeoroid impacts on a solid surface, or a deliberate controlled venting of material from a machine. The argument leans heavily on the idea we should not assume an object is natural just because it's the simplest explanation. Instead, consider all possibilities for a visitor from another star. The call is for a more open-minded approach, not dismissing technology because it's extraordinary. The lack of a prominent tail is another key point. If 3I Atlas were a massive active comet, solar radiation should be creating a visible tail. Its absence, they argue, is a significant deviation from expected behavior. Could the object be thin and solid, like a solar sail pushed by starlight, or a craft with a hull not composed of ice, therefore not producing a tail? These are speculative questions arising from the data. What if? What if the fuzziness isn't a coma but designed to look like one, celestial camouflage? This perspective urges the scientific community to invest more resources into getting a closer look. Proponents say don't be hasty based on only 2 previous interstellar visitors. Advocate missions to rendezvous with such objects, and more intensive study of reflected light for non-natural signatures. Their core point, not certainty, but a firm belief the possibility is significant enough to warrant serious, unbiased investigation rather than premature dismissal. The debate surrounding 3I Atlas does not exist in a vacuum. It is heavily influenced by the memory of our very first interstellar visitor, Oumuamua. Oumuamua zipped through our solar system in 2017. Oumuamua was, in many ways, even more perplexing. It was small, it was highly elongated, or perhaps pancake-shaped. It displayed no coma or outgassing whatsoever, yet it exhibited a slight but distinct non-gravitational acceleration, a tiny push away from the sun. That push couldn't be explained by sublimating ices because there were no ices to be seen. This anomaly led Avi Loeb to propose that Oumuamua could have been an alien solar sail. The mystery primed scientists and the public for the idea that not all interstellar visitors are simple comets or asteroids. It set a precedent for the unexplained. When 3I/Atlas arrived, it appeared much larger and showed a faint coma. Many saw 3I/Atlas as a resolution to the Oumuamua puzzle. They argued Oumuamua was just the smaller example of a class that includes 3I/Atlas. Maybe its outgassing in 2017 was simply too faint for us to detect. In this view, 3I/Atlas normalizes Oumuamua, placing it on a spectrum of natural interstellar objects. But for proponents of the alien hypothesis, 3I/Atlas deepens the mystery. If Oumuamua was technological, a scout or probe, then what is 3I/Atlas? So, let's summarize the arguments and weigh the evidence as it stands today. On one side of the cosmic scale, we have the Comet hypothesis. This position is supported by the most direct and compelling evidence we have gathered. The spectroscopic detection of water, carbon monoxide, carbon dioxide is a powerful indicator of a natural, icy body sublimating under the heat of the sun. This is a known, well-understood process. Furthermore, the object's trajectory is a perfect gravitational curve, with only a minor push that is consistent with the gentle rocket effect of cometary outgassing. We have a precedent in 2I/Borisov, a confirmed interstellar comet, which makes 3I/Atlas the second of its kind, not a complete unknown. The comet hypothesis is elegant in its simplicity. It fits within our existing models of how solar systems form and evolve, with vast numbers of icy planetesimals being ejected into interstellar space. The discovery of such objects is a predictable outcome of our improving telescopic capabilities. In this view, 3I/Atlas is a spectacular natural phenomenon, a messenger from a distant star system that teaches us about the chemistry of other worlds. As 3I Atlas continues its majestic, silent journey through our solar system, the debate over its true nature encapsulates the very spirit of scientific inquiry. We are faced with a profound cosmic mystery. We are using the tools of reason, observation, imagination. The overwhelming consensus in the astronomical community, backed by strong spectroscopic evidence of water and other ices, points toward 3I Atlas being a massive and magnificent interstellar comet. It is a natural wonder, a time capsule from another star system offering us a glimpse into the universal processes of planet formation. This explanation is logical, evidence-based, and fits within our current understanding of the universe. Yet, we must also acknowledge the value of the alternative perspective championed by thinkers like Avi Loeb. The hypothesis that 3I Atlas could be an alien artifact, while highly speculative, serves a vital purpose. It forces us to question our assumptions, to scrutinize the data for anomalies, and to keep our minds open to possibilities beyond our current experience.